call this one B. Which one of those two has a higher speed? Again, whichever one, if you compare points on here, you could really compare any point on this, but we'll look at the speed point, which again, our speed point is defined as what? Very good. Okay, so we'll say with these films, their base plus fog was maybe 0.2. So the speed point would be 1.2. It's optical density 1.0 plus the base plus fog. So then you compare where they intersect at, and this one maybe we'll say used 1.3 log exposure, this one maybe 2.4. Just throwing some numbers out there, you don't have to have these numbers memorized. Well, you do have to know the speed point. That's a number you should have memorized. Optical density 1.0 plus your base plus fog. So how do we know that A has a higher speed? Well, whichever one of these films gets to its speed point first, which this one only took 1.3 and that one took 2.4, is going to have a higher speed. Those two films, which one would have a lower contrast level? B. Very good. Why do you say that?
Shallow slope.
Okay. The slope is not as steep, and it gradually goes up. You could also say that the gradient would not be as steep either. Again, gradient, if you, let's say this is 0.25, this is 2.5. If you connect the lines there, you connect the lines there, and then drew a straight line connecting those two dots. Okay, which one of those, if you imagine those were an incline that you're climbing up, which one is steeper? Definitely letter A, which means the gradient is higher and a higher contrast. Letter B, more gradual gradient, lower contrast. So you pretty much guarantee that if it's got a steep slope, it's going to also have a higher average gradient, which means it's going to have a higher contrast. All right, of those two films, which one is going to give you better resolution? B, exactly. Because it's slower, so we know that the advantage of high-speed film is that you don't need to use as much technique. The disadvantage is it doesn't give you as good a resolution. All right, last question. Which one of those two would give you more latitude?
B.
Also B. Very good. So essentially with this film, you've only got from here to here to work with. This film, you got all the way from there to there to work with. So you got a much wider latitude with film D. More room for error, which means your technical factors don't have to be as accurate. Now let me ask you this while we're on the topic of exposure latitude. Do you think, now we said film B has a wider exposure latitude than film A, correct? Do you think film B would have a wider exposure latitude than digital imaging?
No.
It definitely would not. Digital imaging will always have a wider exposure latitude than anything that we do in film. And that again is because what we talked about last week, the automatic rescaling that's done with your histograms and your lookup table. And not only that, but also you have to throw in the post-processing manipulations that you can do to kind of tweak your image after it's all been run. With film, obviously, we can't do any of that. Our technical factors are going to control how the film looks. We can't adjust it after it's been processed. So, in other words, you don't have to know your technical factors nearly as good in digital x-rays you would in film-based x-rays. And I've got a former student that is learning this firsthand. She called me over the weekend because she got a job working for a mobile company that only uses film, and she only used digital out at clinical sites, and she asked me how she could figure out her techniques. She starts today, actually. And I told her good luck. That's why you guys are writing your techniques down on your clinical logs, you know, even though after you, hopefully you guys